Mhm. Welcome to the Woodbridge Geometry Virtual Tutor. We are going to be working in the right triangles and trig unit. Your objective for today is to solve for the missing side of a right triangle using Pythagorean theorem. So talking about Pythagorean theorem, what you need to know is this theorem only applies for right triangles. So only in right triangles. Your equation here, a squared plus b squared equals c squared. So if we're looking at the triangle, we know it has to be a right triangle. So that means we have to have a 90-degree in it. We know there's 180 degrees total in a triangle. So the sum of your three angles in the triangle have to add up to 180. So if you have one 90-degree angle, that's the largest angle in the triangle. That angle is across from the largest side. That is called your hypotenuse. That's going back to your triangle properties, biggest side, biggest angle, biggest angle, biggest side, right? That works vice versa. And same with your smallest angles across from the smallest side. Smallest side is across from the smallest angle. So in our right triangle, we know across from the 90 degrees your hypotenuse, and your other two sides are the leg of the triangle. So going back to our equation now, we know the legs are being squared and we're adding them up. So that A and B are going to be represented by your legs. And C has to be the largest because we're combining the two legs and squaring them together. We're getting that squared sum. So the hypotenuse is going to be your C value squared. So we know the hypotenuse is C, and your A and B's are your legs. You can interchange your A and B, so if you flip-flop and make it B and A on the sides, that's okay because you're adding. When we add, order does not matter. When we're subtracting, it would matter, but however, in Pythagorean theorem, it's addition. So A squared plus B squared equals C squared. Let's try a couple examples. So, examples here, we're going to keep all answers in simplest radical form. That means absolutely no decimals. If we can't have decimals, we can't have fractions. So when we're solving Pythagorean theorem, you're either looking for a missing side of the triangle, so one of your legs, or you're looking for the missing hypotenuse. So in number one, they give us two of the three sides, so we automatically know two sides, a 90-degree angle. We can use Pythagorean theorem to find the third. So 90-degree angle is across from the largest side. That's your hypotenuse. So a squared plus b squared equals c squared. And we know c is your hypotenuse always. And then 6 and 13 are your legs of the triangle. So we just substitute in. For a, we labeled that 6. So we would have a 6 squared. For b, we have 13, so that becomes 13 squared is equal to our c value, which is x. We're trying to find that variable, so we'll have an x squared. Now we simply just square everything. So we have 6 squared gives us a 36. We have 13 squared, so 169 is equal to x squared. Let's simplify that left side. So we're going to take the 169 plus the 36 to give us a 205 is equal to x squared. We need to find x, not x squared. So to get rid of a square, we do the opposite. So we need to take the square root of x squared and take the square root of 205. Square root of 205 is just the square root of 205. It cannot simplify any further. That's because 205 is going to be 5 and 41. So 205 simplifies to 5 and 41. Both these numbers here are prime, so it can't pull anything out. So when you're working with radicals, you're thinking of that buddy system, and we don't have buddies. 5 and 41 are not the same matching number, so we can't pull anything out of the square root. That's leaving us with the square root of 205 is equal to x. So you found the length of your hypotenuse. And technically we have units on this, so we should put miles there. Example 2. First thing we do is identify our 90-degree angle. We know the 90-degree angle is across from our hypotenuse, so we found our c value, so the square root of 257 is the square root. And we know our other two sides are our legs, so our a and our b value. If you look at where our variable is, so our x, we know that's a leg. So this one's different from number 1 because in 1 we found the hypotenuse. This time we have to find one of the sides or one of the legs. So going back to our theorem, we have a squared plus b squared equals c squared. We know a here is x, so we have an x squared plus our b value, so 12 squared, is equal to the square root of 257 squared. We know x squared is just an x squared. 12 squared gives us a 144, so plus 144. And anytime we have a square root being squared, we know they cancel out, so we are left with a 257. So the square root of 257 squared is 257. That's what's underneath your radical. We need to get that x squared on a side by itself, so we're just going to subtract 144 because that's the opposite of addition. When we do that, we're left with x squared is equal to 113. We need to get x by itself, so opposite of squaring something is taking the square root. So we were left with x is equal to the square root of 113. Again, 113 does not have any other buddies that you can pull out, or it can't be simplified, so you have x is the square root of 113. At this point in time, I want you to pause the video and go ahead and try number 3. So first identify your 90-degree angle, and then your hypotenuse, and then substitute into your equation. So go ahead and hit pause and complete number 3. All right, so welcome back. You were supposed to work on number 3 here. So first thing we do is identify where your 90-degree angle is. We know the side across from that is your hypotenuse or your c value, making your other two sides of the triangle your legs. We know Pythagorean theorem is a squared plus b squared equals c squared. Your a value is a 9 squared plus your b value, the square, or 5 times the square root of 2 squared, is equal to your c value, so x squared. So remember, if you switched your a and your b values, it's okay. The key here is you have to identify that hypotenuse. If your hypotenuse is incorrect, your whole equation is set up incorrect in order to get the wrong answer. So make sure your c is correct. A and b can be interchangeable. So we know 9 squared gives us an 81, plus we have 5 times the square root of 2 squared. I want to talk about that for a moment. When we're squaring that, that can really be broken down into 2 parts. So we would get a 5 squared times the square root of 2 squared. And we know 5 squared gives us a 25. And the square root of 2 squared is just a 2 because we know a square root and square cancel out. And 25 times 2 gives us a 50. So when we have 5 times the square root of 2 squared, that gives us a 50. Which 81 plus 50 is going to equal an x squared. So let's just combine those. We get 131 is equal to x squared. We know we need the square root to get x by itself. So x is equal to the square root of 131. So to recap, Pythagorean theorem only works for right triangles. you want to make sure you have a 90-degree angle. Locate that. The side across from your 90 degree is your hypotenuse, which is your C value. And then your other two sides of your triangle are your legs. That's your A and your B. And then you can just go ahead and use A squared plus B squared equals C squared.